Hello and welcome to another video in cybersecurity series, and in this video we will be discussing something interesting. Since you have already learned SQL injection, understanding this concept will be easy, and what we are going to discuss in today's session is command injection or cross-site scripting attack, which is popularly known by this acronym XSS. Now you may be wondering, why is it not called CSS and why is it called XSS? Well, because CSS is an acronym which is already taken for cascading style sheets, and that's the reason why cross-site scripting attack is popularly known by this acronym XSS. So please don't get confused with CSS and XSS, both are different. So how is this attack launched? Now I'll give you a very high overview of how exactly is this attack launched. So let's assume there is a benign website, and let's assume the domain name of that website is benign.com, and you are a customer or the client of this website. Now hacker identified that benign.com has certain weaknesses or vulnerabilities, and using those vulnerabilities, by exploiting them, he injected some malicious script. So the moment this malicious script is injected somehow, let's fill that answer later. But right now assume that he identified certain vulnerabilities and he injected some malicious script here. Then the browser doesn't know that benign.com also has some malicious script. So since browser is not able to distinguish whether the benign.com code has any malware or no, it's going to just execute whatever it is going to receive. So in this case, after the attack was launched, the browser is going to load not only the benign website, but it is also going to load the malicious script along with it. So what happens because of that? Here the end user becomes a victim. Now that malicious script can be doing anything serious. It can be a keylogger where it is logging all the information or the keystrokes of the end user and sending it to the hacker so that he can bypass the login altogether, or he might be stealing some sensitive information like session IDs or cookies, or he might be doing anything else, or plainly blocking the actual website. So the impact of the attack can be anything, but here it is very clear that he is injecting some malicious script into the otherwise safe code of the benign website. Now right now it may seem like magic because I did not explain you how exactly is the code injected. Well, we'll understand that in the next slides because the methods of injecting the malware are slightly different. So in essence, how is the attack launched? A malicious script is created by the hacker and he is going to inject it through the input fields or request parameters since they are not sanitized. And how does he do it? How does he make it possible? Let's discuss that in the two main types of XSS attacks. So XSS attacks, if we talk, they are broadly classified into two main categories. The first is called reflected XSS attack, and the second is a stored XSS attack. So what happens in a reflected XSS attack is whatever the malicious script the hacker is injecting into the benign website doesn't get stored on the web server. It is momentous, as in whenever the user clicks on a specific link, this script gets run on the browser and the victim and it's going to impact the victim. So it is not stored on the web server, it is not stored anywhere. And hence, it is known as type 1 or non-persistent attack. Non-persistent meaning it is not stored on the web server. So it is reflected off the web server, it is not stored on the server. But how does it happen? We'll understand that in the next slide. So let's say this is the scenario for reflected XSS attack. We have the hacker here and he has identified benign.com as the website that he wants to exploit, and there he saw that there is a request parameter in the which is allowed in the get request of the website, and there he is injecting some script. So as you can see, this portion that I highlighted, he identified that it is taking some input parameter through this request, and there he injected some script. Now that script gets executed and it shows as a alert box in this case. So this is a real-time example where you can see the search parameter Q is modified to script alert reflected XSS attack. Now this is made possible. Because this search parameter Q is not being validated or sanitized anywhere. And that is the reason it is just making a request to the server and coming back to the user in the form of an alert box. Now this is only for illustration purpose how reflected accesses attack actually works, but it can do something very serious as well. Right now it's not stealing any data, it's not stealing any cookies, or it's not manipulating the behavior of the website to a very high impact attack. It is just displaying that a reflected access attack has been launched. But much more serious things can be done because there is a loophole in the website where the input can go into the server and get processed there, and since there is no proper validation or sanitization, it is getting reflected back to the end user. And this is, let's take a quick look at the backend code which is allowing this reflected accesses attack to happen. As I told you, we are making a GET request at this endpoint search. Now this is receiving the request headers, and this is the line of the code which is allowing that reflected accesses attack to happen, because it's directly concatenating the message to the response value. So this is getting returned to the user, but here there is no check which is happening in the first place. So we are directly concatenating this value along with the message that we want to display to the user, and hence the alert box is getting displayed to the user. So in this case, the major reason for this attack to happen is that there is no proper sanitization in the backend. This is the essence of reflected accesses attack, that a benign website was identified and the search parameters have been manipulated. But here comes a very important question. When the URL was handcrafted by the hacker, how does the victim know that? So hence this question mark. Now I am an end user, I don't know what the hacker is going to inject. So how will I even fall prey to this attack? Well, it is something like this. It is through social engineering or through phishing that you might receive this link which has malware. And when you think that this is coming from a trusted source, because benign.com is a website that you use on day-to-day basis, you think that this is coming from a trusted source and you just click on it blindly. Then what happens? This benign website plus malicious script gets executed. And as I told you, the malicious script can be anything. It can be a keylogger, it can steal some data from the website, or it may be blocking the actual website. So do remember that in case of a reflected accesses attack, there is no information which is stored or persisted on the web server or in the backend, but this handcrafted URL is sent to the end user in the form of a phishing attack or through some social engineering techniques. Now coming to the second type of the accesses attacks, as I told you, there are broadly two categories, that is reflected as well as stored. Now moving on to the second type, the stored accesses attack, which is a persistent attack. In this, what happens is the malicious script, the script which is injected by the hacker, gets stored on the web server. So it is either stored or persisted, both of them can be used synonymously. So it means that whatever malware script or the malicious script that the hacker is injecting, it gets stored on the web server. Remember this very keenly. So in this case of a stored accesses attack, this is a quick illustration for you all to understand it easily. So here there are no request parameters in the URL, but yet the hacker has identified that using some input fields, he is able to inject the malicious script. What happens is it directly gets stored to the database of your web application. And every time the end user visits this website benign.com, the browser is going to load benign website plus the malicious script. So in this case, the hacker is not going to handcraft a URL, rather he is going to push that malicious script to a database. So every time this web page is served, it loads the malicious script automatically. So the burden of the hacker is reduced in this case, because any visitor of this website will be impacted with that malicious script. Whereas in the case of a reflected accesses attack, the hacker, if he is successfully able to send the handcrafted URL with malicious script, if the user clicks on it, only then that malware script is going to run. But in this case, since he was able to put the malicious script on the database directly, every user who is going to visit the benign.com will be impacted. So in this case, the workload of the hacker is reduced. So again, the malware script can be anything like keyloggers, it can do data theft, it can block an actual website. But here in this case, there is no phishing attack or social engineering that is needed. It is the database which is going to serve the web page directly. So here's a real-time example where the hacker has exploited the website and then he injected some malicious script into the database. So every time I click on localhost 8080, it is going to load this. And why? We will see that in the live video. I will show it to you hands-on how exactly this happens. So I'll explain how the reflected accesses attack is made possible. I will also explain how stored accesses attack is working along with the access to the code so that you can run it at your end and test it. Now a quick look into the backend part, the backend code. Now this is the post request which is going to the products and this is the request object. Now the user is going to send some script, as we see in this example. It is script alert stored accesses attack. So that is the input which the user is going to give to this post request, and here we are just looking at the request body name. We are not validating anything, we are just pushing whatever we receive to the products list. So there was a products list which had these values apple, kiwi, and the second is blank here because it is stored accesses attack. This is the script which is there running on the browser. So the second element, which is script, the script tag also got pushed to the products list, and that is happening because there is no validation here. Whatever we receive, we are directly blindly pushing it to the products list, and that is being sent back to the browser whenever we are displaying, and hence we are seeing a stored accesses attack. So now since this is stored in the database, any user who is connecting to this website will still see the stored accesses attack alert message every time he visits the page. Now we discussed reflected accesses attack and we also discussed stored accesses attack, which are main categories of an accesses attack. Now there is a least known accesses attack, but it is, you come across the term whenever you read certain blogs on accesses attacks, and that is DOM accesses attack. It is also called as type 0. Reflected accesses attack was called type 1 or non-persistent, whereas stored accesses attack was called type 2 or persistent. DOM accesses attack is type 0. What happens in the case of a DOM accesses attack is that script is injected by manipulating the DOM elements on the website. So in the previous cases, what we saw, in the case of reflected accesses attack, the script was injected using the query parameters, whereas in the case of a stored accesses attack, the input fields which were taking input, which was not validated, they were used for launching the stored accesses attack. But whereas in the DOM accesses attack type, the script is directly injected by manipulating the DOM elements of the website. Now that we discussed the three types of accesses attack, this is a summary of the accesses attack so that you understand everything and also remember it. So the malicious script is injected into the website, that is the essence of accesses attack. The browser will load the website along with the malicious script because there is no way for the browser to distinguish whether the code that it is loading is safe or no. Since it is coming from a trusted source like benign.com, it is just going to execute whatever code it receives. Now the malicious script can access, it can do anything, that depends on what hacker is actually injecting. It can do much serious stuff like stealing sessions, session IDs, it can steal cookies that are stored on the website, or it can steal any other sensitive data. Now with this knowledge, you have to solve these three challenges on Juice Shop. The first two are very easy since they are 1-star rating. DOM accesses attack, bonus payload, they are almost similar. They can be solved quickly. And then you have a reflected accesses attack, which needs you to explore the website a little more in order to solve this challenge. But once you understand these two challenges and once you are able to solve it, then you can quickly solve the reflected accesses attack also. In case you are caught up not able to solve it, then do revisit this video again, visit the reflected accesses part of the explanation so that you understand where exactly to look for vulnerability in the juice shop website. So this is a description of the exercises. Input fields and query parameters in juice shop website, some of them, not all, are not sanitized. So you have to look where exactly are those fields which are not sanitized, and once you identify those vulnerable input fields or query parameters, you can launch the attack and then the challenge is solved. So the main thing here is you have to look for the query parameters and input fields which are not validating the user input data. So that will take little bit of exploration from your side, because there are many input fields in juice shop website. There are many URLs where you are supposed to look into, probably visit different pages in the website and see where exactly the URL has a query parameter. So do explore all the features in juice shop, and this is going to be little trial and error basis of solving the accesses attack challenges, but that will help you to understand the different features of the website. So do take some time and solve those challenges. So in the theory video, what you saw was a few code snippets that I quoted, which were causing the XSS vulnerabilities and how it was exploited to cause XSS attacks. That is, different types of XSS attacks. What we saw was reflected as well as stored. Now let's see, with the help of a live code example, how this attack can be launched and how it can be prevented. So I will walk you through the code which is causing the vulnerability, as well as the code which can be used to fix this vulnerability. If you want to follow the same steps, please go to KMIT official GitHub repository, Cybersecurity 2024, which is available on KMIT official on GitHub. From this repository, you will be able to download the code, which I will be explaining in this video. I cloned the same code and now I have the code available here. First, let's see how a reflected XSS attack can be performed. Now let me start this website by running the command npm start. Before this command, you are expected to run the npm install command in order to install all the node packages which are required to run this website. Now once that step is done, this is step 2, which is npm start. Now when I run npm start, I can see that the website is up on 8080. Going back to the website, let me refresh this page. So what I can see here is a demo for reflected XSS attacks as well as stored XSS attacks. Now let's understand how reflected XSS attacks work. I showed you an example of search. This is the search page. Now actually it expects one query value to be passed this way, like q equal to kiwi. But since this product is not available, it shows that could not find the product kiwi. Now, if I think as a hacker, I know that Q is one variable from where I can give some kind of input to the website. So I will replace this kiwi with something like this: script, alert, and XSS reflected. And this is the value that I give for the value Q on a search product page. Now, when I hit enter, what I see is this alert box, XSS reflected. As we already discussed, a reflected XSS attacks means the malicious content which is injected by the hacker is not stored anywhere on the website or on the database. It just gets reflected off the web server. And for that, a hacker has to craft a URL. In this case, I'm crafting this URL because Q is a value which is taking some input from the user. So I tested by giving it this value, which is containing this script, which is a script which is not causing any harm in this case. But since there is a vulnerability, it's getting reflected off my web server. And now, if such vulnerabilities are exposed to the hackers, they can do much serious work by injecting more serious malicious scripts. Now, let's go back to the code. In the code, I clearly highlighted that this is the piece of code which is a bad coding example which is causing this vulnerability. And because of that, when you insert this entire URL, you will be able to see the alert box. Now let me comment this code which is causing the vulnerability. And let me fix this code by uncommenting this code. Now in this part of the code, what I did is encoding whatever input I'm receiving from the user. Now when I encode the input, it will be treated as a string but not as an inline script element. Now let's see this in action. Now since I made the code changes, let me save the code and rerun this code again. npm start, right? So website is now running. Now let me just copy this URL and let me just load the search page first. And now the search page is fine. There are no errors after doing the code changes. Now I enter the same script. That is, now I try to enter this. As you can see, this time we do not see an alert box. There is no alert box. Rather, whatever I entered here in this Q value is just getting appended as a script here, as a script string. So there is no alert box. This is not being treated as an inline alert statement, but rather it's being just treated as a text which is getting appended to this string here. So by doing this encoding step, we prevented a reflected XSS attack. Now you can see here in the code on line 23, I'm encoding the input I'm receiving from the user, and I'm also logging it to the console. And as you can see here, this is the encoded string which I am receiving. Now HE is a HTML entities library which I imported here. By encoding the string, I am preventing a reflected XSS attack from happening. Now that was about the search statement and how a simple few lines of code changes can prevent a reflected XSS attack. We just saw that in action. Now let's go down to the stored XSS attack and how this is happening. Now let me not reveal the code completely to you. Let's go back to the home page. On the home page, here we have the option to add products. So let me add this product, Kiwi, and click on OK. So it says this item was added successfully. When I refresh the page, I can see that this product is there in the list. Now, since this is taking input, let me do the same thing here. Script alert, and I enter the string stored XSS exclamation, and all right. So this is what I'm inserting. Now, since I'm thinking like a hacker and I'm doing a trial and error to see whether this input field is vulnerable to XSS attack or no, I am inserting this script to check. Now I click on OK, and the message says it is successfully inserted in the products list. Now, in order to see whether it's added or no, I have to reload the page. So yes, it is now added to the list of products and it is also getting executed, and that's the reason I'm able to see this alert box which is showing me the message that I inserted. Now I click on OK. Now the third is the script that I inserted, so it doesn't show as text here, but let's go to inspect element and see. Right here I have the malicious script that I just injected. Now let me try inserting another value. Let me try adding grapes. It says okay, success. Now let me reload the page. And again, I see the alert box because it is one of the items which is added to the products list. And now there is this fourth element which is grapes. So as you can see, no matter how many times I reload the page, this gets loaded every time. Even if you type the same URL in another browser and try loading the page, you will still be able to see the alert box. And this is happening because whatever script I injected got stored in the backend. So once I'm able to identify a vulnerable input field through which I can inject the script and store it permanently on the website, then I don't have to worry about crafting a URL. So I persist whatever malicious code I have on the website's backend, and every time this web page is loaded by any user on any part of the world, he will still be able to load the malicious script. Now, in this case, it was just an alert box, it is not causing any harm, but much more serious work can be done on similar lines if you have any input fields which are vulnerable to XSS attacks. Now, let's step back and look at the code. In the code, I clearly highlighted here that this is the part of the code which is causing XSS vulnerability. And why this is causing the vulnerability? Very clearly, because we are appending the data we are receiving from user as it is, without validation and without encoding. Now, as a simple step, what I will do is I will comment this code and uncomment the good coding practice and uncomment this code. In this code, I'm just encoding the data that I am receiving from the user. Now, since I made this code changes, let me save the file and restart my server. All right. So let's reload this page. Now it is having only one item, that is Apple. Now let me add the same script. So it says this whatever string I inserted got added. I click on OK and I refresh the page. Right now, I'm able to see what I inserted. Okay, so this has a typo, but let me retry again. There is a T missing. So yes, now it is right. Click on OK. Now again, let me reload the page. Even after fixing the typo, as you can see, this is just getting appended as the third item in the list, but it is not getting executed as a script which is inline. Let's check the values here. And additionally, what we see here is double quotes. So this is saying the browser that this is part of the text but not an inline script. So when the browser loads the code, because there is a proper encoding in place, the inline script is not getting executed. So we are saving the website from a stored XSS attack. Now this is just a very basic example to give you an example of how reflected XSS and stored XSS attacks work and how we can fix them. But I encourage you all to explore further to look at more serious examples which have much crafted URLs or different approaches or much crafty approaches of launching this type of attacks. So go out, search for better examples, and try to play around with those code samples. Thank you.